Hello guys, so for my first tutorial I'm going to show you how to do this kind of magical orb effect on Houdini and rendering with Mantra. So this is meant for beginners, so I try to make things as simple as I could. Cool, so let's dive into Houdini. So we're going to make a Geo Object and rename it properly. So let's go up. And then we're going to dive inside and put a simple sphere. So here we have our sphere. So we want the sphere to be a mesh and to be at 0.1 in scale. Here we are. And we also want to have maybe a little more subdivision for later. Should be good like this. Okay. So we have this sphere and we're going to apply a noise on it in the color to drive our emission. So let's have a VOP and we're going to name it noise source. And we're first gonna try with a regular noise. So let's drop a turbulent noise. We want to noise the position and to put the noise into the CD. So here we are. We're having a noise in the color of our position. So here you can see it's pretty static. So obviously, because it's based on the position and the position is not moving. So we're gonna promote a few parameters here so we can change the look of the noise. So just right click on the node, Vex VOP option and create input parameters. So at the sub level you can find all your parameters and play with them. So I'm going to make a bit more in the frequency and change this to sparse so it's way more contrast and it's easier for visualization. So here I have my noise and you can see it's not moving. So with this kind of noise, with a vector input, a regular vector input like this, we can't make the noise move using the offset. So the offset, what it's doing, it's actually making the noise slide in the axis. So here it's in the x-axis, so you can see the pattern. You can see it sliding to the right, You can obviously see it sliding. Same for the y-axis, it's sliding to the y, sliding up and down. So it could make the trick, Like you just put a $T, which is for the time expression. So as you can see at 0, it's at the beginning, and at frame 25 it's at 1, because in 1 second you have 25 frames, etc. We could do that. It makes the noise move. We could also use the $F function, which refers to the actual frame. So as you can see it's 1 and then it's evolving frame 30 according to the frame it is. We could multiply it if it's too fast or if it's not fast enough. But this thing is making our noise slide, so it could be good, it could be great for, also it could be working for this kind of effects. But I'm just going to show you another way to make our noise evolve also. So I'm just going to drop a brand new VOP here. Here we go. Okay. And here I'm just going to use another kind of noise, the anti-aliased kind. So I'm going to pick this one. And what's good about this kind of noise is I can feed it a 4D input. So here we go. We want to convert our regular vector, which is our position, to a vector 4. So what I did is I chose this guy. And you can see you can plug another thing here. So we're just gonna plug time. So don't be scared about this yellow color, it's okay. It's a vector 4. And then you're gonna put it in the CD. So what do we have here? We have a noise that's evolving without making any kind of expression. So here you can see we have all the 3 colors. We only want to use one of them, so I'm just gonna decompose the vector into the 3 float with a vector to float thing. Where it is, vector to float. Here we go. And so you can see it's R, G, and B. So we can see our geometry spreadsheet. The color is made of is made of 3 floats, so X, Y, and Z are red, green, and blue channel. So here I'm just gonna pick the red one, but I could have picked, it's up to you. So here we go. I'm gonna also promote these parameters here, and we can change this guy. So yeah, this one thing here. Oh god. Yeah, okay. Yeah, I don't know if it's about this version, but sometimes it was not updated. So if it's not updated, just go there and change it back to 3D. Okay. So here I have an evolving noise. It's not sliding, it's really evolving. You can see the shape is evolving. But it's way too fast. So we want to create another parameter to control the speed. So I'm just going to drop a parameter thing and call it speed. Here we go. And as I did with the $T and $F thing with the regular turbulent noise, I'm just going to multiply the time with the speed. It's just like I did this. Times something. Okay, so you can see we have our attribute speed right here. So at the moment it's at 0, so nothing is going on. So I'm just gonna put 0.1, so it's a bit slower than it was. So we have a nice evolving noise. It's cool. So right, maybe I'm just gonna change a bit these frequency. So if you don't know that already, just right click on copy parameter and you can right click here and pass relative reference. So it will always refer to the one of the frequency. So here it's the X. That way, oh, oops, sorry, you don't have to always copy and stuff. So, okay, we're gonna just put, maybe go to 50. So yeah, we have this kind of noise. Maybe 25 should be cool. Okay. Alright, so now that we have our density or kind of emission map, we're going to use it in the scatter. So here we go, just put a scatter. And here you can see that our points, there you go, are evenly scattered around the sphere, and this is because of this option. So we want to uncheck this option. Also, this option is way easier to compute. So if you have a heavy data or something, just know that this option will make the scatter longer to compute. And also it creates way more organic distribution around the sphere. But here you see we have points all around the sphere and not just on the white area. So we just want here to put CD. That way it will, you see it's scattering only on the area that we have according to our noise that we did just previously. So the source is not really stable, as you can see, but in this case we don't need stable source, so for once let's enjoy this luxury. So okay, I'm just going back to dark because I prefer working this way. So we have our points, and now we need to give them a velocity in order to make them move in our pop network. So here I'm gonna be lazy and I'm just going to say V equal P. So what is going to give me? It's going to give me this nice radial initial velocity, which is completely what we want. So that's great. Okay. And now I think we're ready to feed it into a pop network. So let's type our pop network. Here we go. We have our pop network. That's great. So let's dive inside. We want to uncheck this because it's a bit annoying, and we want to save emission type as point. Okay. So here we are. We want maybe a bit more point here. Okay. So what it's gonna do right now is going to spread in a radial way, obviously, because this is what our velocity looks like. So to have this kind of shape that we want, once again, we're gonna use noises. So just put a pop-up, dive inside, put your noise here. I'm gonna use a regular noise for this example, but you could totally use the noise that we just saw earlier. Okay, I'm going to noise the position. So yeah, you want to export a 3D noise out of the noise because you want a vector and you want to add this vector to, actually you want to add it to the position itself, and you want to feed it into the velocity. You want to say that the new vector that it's creating in noising the position and adding it to itself is going to be your new velocity. Okay, and we also want to promote this parameter to control what could be the shape of these noises. So let's see what it looks like. So it looks like this. Not really interesting right now. I'm gonna change to sparse because it's my favorite one, as you can or maybe guessed. Okay, not really interesting, but something is going on. So what is happening here is that our particles are kind of following what could be the pattern of the noise that we're applying here. So right now the frequency is at 1, so it's really a big pattern because it's a low frequency noise. But if we increase the frequency here, let's say maybe around 11, you can see it's making its way to another kind of pattern, you know, like you can see. Obviously they're living for too long, so we're just gonna change their lifespan. So let's say to 1.5, oh sorry, 2.2 invariance. Here we go. Yeah. So we're having this kind of interesting shape. So that's great. And so, you know, the more frequency, the more, like you can see, the more tight the path, you know, it's taking, because that's how noise work. Okay, so let's keep it to 10 or 11. I'm also gonna add a little bit of pop force to just add some swirling and add a little bit of variation. So let's say the 10. Okay, maybe it's a bit too much here. I'll let you find your own parameters, you know, the one that you liked the more. Okay, so now we are lacking of something. So as you can see here, I'm having a collision. We're having a collider, which makes this cool kind of contact thing. So as you can see, the tendrils that we have here are actually created by the noise. We can clearly see these tendrils here that we'll have later on. So let's create our collider. So for a collider, I actually need a Geo and a VDB kind of SDF version of it. So we want actually to be a sphere here, so we're going to do mesh also. I'm just gonna bypass this. I mean, make the green, the pink thing, and just to find the right scale for the collision. So maybe let's try something like 0.6 or 0.7. Okay, and okay, so we are our sphere. We're gonna make a VDB from polygon out of it. So we have our, oh sorry, I did the wrong input here. Okay, we have our VDB, maybe just make it a bit more defined. And okay, so we're just gonna plug some null so we can call them easily in the pop network. So out collider geo. Oh, and out collider STF. Okay, let's go. And now we're going to import it in this pop network so we can have our collision. So just put a static object here. In the subpath, we want to get our collider geo. Right here, our geometry is not moving, but if it was, don't forget to put this kind of stuff. Okay, so we want a volume collision. We want the volume sample, and we want by size. So the proxy volume is actually the SGF that we just created. I'm just gonna go back here and copy this parameter. Right click, copy the parameter. Go back to my pop network and paste the variety reference. That's why it's always the same division size, you know. And I'm just need to merge. So when you're merging a static object to a solver, don't forget that it always have to come first here. So you can change your order here, like you can see here. I want my static object to be computed first. I don't want to see it, so I'm just gonna click here to just don't see it. So you can see it's not going to work. It's making this weird thing like, oh no, my collision is not working. Because it's actually because there's another option since it's inside and you want to collide like the inside, I would say. You have to click this thing, the invert sign thing. So yeah, we have our nice contacts. Okay, so we can start with that. We could totally make your own, make it more interesting, making an anti-alias noise, check different kind of noise, make the noise evolve. It's really up to you. You can, I would just leave it here because I don't want to spend too much time, but here we go. I just want to show you the basic and then you can tweak it however you want. So we're going to use this kind of base actually. So at the moment I'm using a very slow laptop, so in usual way to make this kind of effect you will need as much point as possible. So depending on your machine you can go really far in here. For me I'm just going to go to 100,000. Yeah, I'm just gonna go there. But if you can go way more. And so, but also we want a lot of particles, but we are going to get some wedges. I will explain to you. So just drop a .io because we want to import the data from our DOP network. So just drag and drop here. We want the particles. And here we just want the object name, so here it's clearly pop object. So yeah, so if you don't know what the object is, it's just this name here. Here you go. And now you can see it's only importing the particles, it's not importing all the stuff that's inside. So here the collider or what could be something else. So here we go. We want to clean this before writing it, so we don't have all kind of attribute we don't need. So I'm just gonna put a bit here. So we want to keep the age, ID, and life. Okay. So here I have all the things that I want. I just need to check delete non-selected. So I only have the one that I want left. I'm also going to clean the group, so it's just make cleaner caches. Okay, here we go. And then I'm just gonna put null and here we go, out simulation. So I was telling you that the perfect way to get this kind of looks for magical effects, it's actually having as much as particle as you can and having them as thin as possible. Um, I don't have much particle in this render, so I would have loved to have way more details and depth, but I couldn't go really far with my laptop. But you can see that you have this kind of tendrils. It creates kind of depth and different layer of opacity, and these are just linked to the number of particles and their p-scale. So what is good to do here is actually make wedges. So what a wedge is going to create several simulation based on the same and unique one, but with one or several parameters who are slightly changed. So here we want to do the same simulation, but we want just to change the source a little bit to have almost the same simulation but slightly offset. So as you can see, if we change the seed of our scatter of the sources, it's basically kind of the same, but our points are not exactly at the same place. So obviously, and this will create several simulations that almost look the same, they are behaving the same, but the points are slightly offsetted. So this is the kind of details you create. The more you have particles around the same place, it will create this kind of tendrils. And here they are almost at the same place, so it will create more thick areas. I don't know if that makes sense, but I will show you how to do these wedges. So I used to do them in the out context, but here we have new tools such as Top Network. So I'm going to show you quickly how to use it. I'm really not a pro of Top Network, but I found a way just to use it how I needed to. So I'm just going to show you quickly. So dive inside the Top Network and call a wedge. So here we have our wedge thing. So we want to wedge one attribute. We also want to preserve our wedge number. And so we want to wedge one attribute. So this attribute, we are going to tell him what it is. So I'm going to go to select my scatter, which is used for the sourcing. And for the attribute name, you want to find it by going on your scatter node, and you can see that this name is parameter density attribute. Density attribute is the name of the parameter. So here we want seed, so thanks God it's just seed, so pretty straightforward. So I'm going to write seed here. So what is gonna do, so for example, I'm going to say that I want 20 wedge, so I want 20 simulation of the same simulation but with different seed from the scatter of the source. And I'm going to say that I want random samples, so it creates random values for this scatter, and I'm just gonna put a very big number. So it creates the seed. It will create random values for each 20 times between 0 and whatever I'm saying. So yeah, so it could be either B's or B's, you know. The important thing is that these values are random and different. So I've set my wedge, so I need to say what to wedge. So I'm going to put a wrap geometry output right there. And I am going to put the render flag here. In the subpath we want to put our out simulation like we just said it, and this kind of thing is actually a bit like your file cache, usual file cache here. So we want to set the name of the file and the frame range and stuff. So I'm just going to do frame range. There's a lot of option if you have a farm or whatever. So just here, I'm just going to do this because it's a simulation. And we want to maybe put this kind of information, so that way it will, this wedge index is referring to which wedge it is saving. So we have different file for each one of our wedge, so it won't write on itself, etc. And once you have everything set, just you can click there and let the magic write itself on your computer. Okay, so now I have all my wedges loaded in, so I just put them in a subnetwork so it's more convenient. So okay, I have all my particles here, so you can see I only have like around 3 million of them, which is really not enough for this kind of effect usually, but I can go really higher. So I'm just gonna put in the display option, so I just click D in the viewport, go in geometry in point size. I'm just going to put it in 1 because when I have a lot of particles I find it more convenient to look at if the scale is smaller in the viewport. So as you can see, I'm having all kind of tendrils and details and stuff. So right now all we need to do is apply color and render and p-scale, all kind of things. So I'm just gonna create a random camera, so maybe run here and create control and click on camera, so it will create a camera. Alright, I'm gonna call it cam render. Okay, so let's dive inside. Okay, so I have all my wedges, and now we're going to set the look in a little 2 lines of wrangle. So in vex, it's not, you see, it's not that big deal. So set look. Okay, so we're just going to ramp the color according to the age of the particles. So we could do it in different way. So sorry. So v at cd, because our cd is a vector, and we're going to just ch ramp. Going to call this ramp cd, and we're going to do fh to divide by h f at life. Okay. So what this thing is doing, it's exactly the same as if you did this. So fit age between 0 and live and go back to 1. It's actually making a ratio of the age of the particles between 0 and 1. It's like kind of a percentage of the age of the particles. So we click here to generate the ramp. And so when the age is at 0, the ratio is at 0, and the more it goes toward its life, so the more the age value goes towards the life value, is going to 1, and once it's at 1, the particle is dead. So we create this kind of ramp, and you can see right now I'm having a black and white ramp, obviously, because it's automatically generate how is that, a float ramp, but we want a color ramp. So I just click here, edit parameter interface here, and color. Okay, apply. So now my ramp type will be a color, and you can see it's actually a color, and now I can change and make all kind of different color that I want. Maybe we go green here, maybe not this green, but yeah, it's how you feel. Okay, I'm like to make my call really bright, so I'm just going to do a really bright white. Like you can see, I don't have a nuke on this machine, but if I had, if you put a value above 1, you could do all kind of values. So the more the value, the higher the highest it is. In nuke, it will react more to the glow if you're putting a glow or something. So I usually make my core a bit brighter. Okay, so let's say this is the color we want, and now we're going also to need an alpha. So the alpha is like the opacity of your particles. So we're just going to do the same thing, you know? We're lazy. So here we go. So here I'm going to say that it's full opacity when it's birth and it's less opacity as it's dying, you know. So you can see we can start to see more of our tendrils, you know. You can see a bit more. Okay. So once we have a look, we need one final thing for our render. We need a p-scale. We need to tell the software at what scale is our points. Okay, so I'm just going to do a simple thing. Okay, I'm just going to make this kind of value first because I know we need a really small p-scale, and just for clarity I'm just going to put this here. Okay. We have a camera, we have colors. All we need now is a material. So for this kind of emissive and simple effect, I like to use the glow one. It's pretty straightforward. Okay, so we have the glow. The glow material you see is use point alpha, point CD, and it's like a regular material with an emission at 1, you know. So okay, we want the glow here. Okay. We could also make the orb, you know, rotate a bit. So just put a null around here, and you know, just animate kind of rotation. So here I only have until 150 of data. Okay. We could make, you know, it's up to you. If you do that, don't forget to go in the animation editor. If you want to center your curve, just press space F and go to linear mode, so you won't have a fade in and fade out in your animation. Okay, and now we need to create our mantra rope thing. Okay, we want these, we want this camera here. Okay, we want to put our objects in here. Oops, sorry, we don't need lights. Okay, all right. So here I'm gonna choose this kind of engine. I'm gonna increase the pixel sample so it has more definition, and I also want some motion blur. And to have motion blur, I have to enable it here, and I also need to say it here that I want velocity blur. But for this, you have to check. Oh yeah, one thing I forgot was the velocity, because I did this catch prior to the tutorial. There's something we really want to do before doing all your wedges is put a trail sub here, and yeah, let's say and you want to compute velocity and match by ij attribute. This is something you need to do really here and not after with all your wedges, because all your wedges they will have it's the same simulation, so each of them have the same IDs, and if you want to compute velocity from IDs and several points the same IDs, it will create some mess. So don't forget to do that. It's really important to have really correct motion blur. So sorry about that. And then we're going to go there. Okay. And maybe go there. And okay, so let's render. So as you can see, okay, so we have this kind of render. So we can clearly see that the P scale is way too high. So I'm gonna reduce a bit. So you can see it's really about the P scale. Maybe even more. So you can see we started to feel our tendrils and stuff. So once again, if I add way more particles, it won't feel that spotty, but you have all the keys to make your own thing, and maybe wedges and have million of particles, and you got to play with the p scale. You got to look for the right p scale, and you could also random the p scale, make the p scale according to the life and stuff. But I didn't want to go too much in depth here. I think the tutorial is already long enough. So yeah, so once you get your render and your p scale right, you can just hit render and you will have this kind of result. So uh, yeah, actually I have 3 million particles here. I did a little bit of glow in After Effects, but you know, this is the kind of thing. And here you can see different tests that I did, and yeah, so this is something I did when I was a student and brought me the idea of the tutorial. So you see it's way more calm because maybe the amplitude of the noise inside the pop network was way lower. You can see the frequency here is lower, so the pattern are broader. So you can see it's only going in some direction at a time. Here is way more diffuse and energetic, and you can see you can make all kind of different look. It really depends on your noise, on your velocity, if you want to multiply velocity and stuff. So yeah, just I hope I told you some things that will be useful and you have fun with those. And thanks again for watching, and I hope to see you guys soon. Bye.